All right, Bobby, take it away.
All right, thanks so much. Certainly, thank you guys for all the opportunity today. I know there's under extenuating circumstances, but you know what? Today we're going to spend just a few minutes to learn about research that has been created by Gates over the last couple of years, and we wanted to share that research with you and some of the failure modes associated with that. We certainly appreciate this opportunity. You'll see this will be what we call fast and furious. We only have an hour of time to get this to you. If you'd like additional information, we can certainly either do another webinar or you can reach out to me directly. You'll see at the end of this webinar, there's some additional opportunities for training that you can be had as well. So with that, let's get started. Let's see if I can get this thing moving. And I apologize. The extenuating circumstances were me because my computer decided it wanted to shut down just as I began to log on. So anyway, as we get started this morning, a few things we'll talk about, and that is that a couple of years ago, or many years ago, actually about 2009, 2010, Gates decided they wanted to be prime in water pumps. So uh, we developed our own and created our own water pump line and build our own factories. And with that, today we manufacture water pumps that equal to or exceed the OE quality. But along with that, we began to see challenges along the way. And what we wanted to do was provide these challenges to you guys to help you understand where some of these failure modes are coming from. You'll see we're going to talk about a lot of stuff. We're going to hit a lot of things that you're probably seeing today. Can I answer all the questions at the end of this? Maybe I can't. And if I can't, I can tell you globally we have the corporation that stands behind us that can help us filter through some of these challenges that we may be seeing. So as I begin to talk about this, I've changed my whole mindset around coolant. And today, we have to ask ourselves, should the coolant system be under lock and key? We're going to provide some industry information to you. We'll talk about warranties associated with that. And then I'll share the Gates research throughout this to help you understand where the failures may be coming from. The disclaimer before I go any further from here, Gates fully supports the coolant manufacturer's claim that if you want to see and enjoy the benefit of their products, you must fully flush the system at the time of the repair, and you'll begin to understand why in just a few minutes. So when we talk about should your coolant system be under lock and key, think about that. You may have a customer that comes in and has a lock and key cap on their gas tank. But why would that be? Well, typically it's to keep someone from removing some of that, isn't it? But in today's vehicles, maybe it's the same thing. We need to really begin to look at this differently to think maybe we need the same thing for the coolant system. Now, as we begin to look at this, I really need you to open your mind and think about this differently because this is all based around warranty and product failures. So we began to reach out with manufacturers that had components in the coolant system. Very specifically, it was a radiator manufacturer or two. They manufacture radiators and heater cores. We worked with our own information that we had in and around the water pumps. And the interesting thing is, now I need to put this slide in context for you. When it says 40% of radiator failures is due to condition of coolant, that doesn't mean that 40% of the radiators that are installed are forced to fail by condition of coolant. What it's telling us that when the manufacturer takes that radiator back as a warranty and they do their product sampling or survey to find out what created that failure, of those they looked at, 40% of those were forced to fail by condition of coolant. Look at that bottom red bullet point that's in red. We can tell you from ourselves, and you'll see some of our information in just a few minutes, 95% of water pump failures are due to a no flush or condition of coolant situation. So if 40% of the radiators that are being received back for warranty are forced to fail, and by the way, that number is almost 50% now because of condition of coolant, and 95% of the water pump failures are from condition of coolant, what's the common bond of the failure? This is why we call this System Smart today. Be System Smart really began with our I60R90 initiative back in 2010, and it was really wrapped around the system itself. You'll see that most belts and hoses today have moved from neoprene to EPDM, ethylene propylene diene class M of rubber, and because of that, they wear totally different. The life of the product can be fully extended to really reach from way past the duty cycle of the hose itself. So as you read what's on the left of the screen, and I know that's eye candy, let me spend just a few minutes and talk to you about the graph that you see on the right. The graph really indicates we work with a company, as most major manufacturers do, with a company called IMR, and they do a continuing automotive consumer survey. And this is all based around replacements, not failure modes. Now, we can tell you that for the Gates, when we talk about actual warranties through Gates Corporation, it's less than 2%. So as we begin to work with this company, as they do with most major manufacturers, we gave them the answers that we needed them to ask throughout the survey. And the interesting thing that they came back with, not only on belts, on timing systems, but on coolant systems, that at or around 60,000 miles, the replacement rates begin to go up. Now, I want to make this very clear that this is typically out of the manufacturer's warranty period. See, so this is back out when it's either going back into the dealership or it's coming out into the independent side, where it will be serviced. At 90,000 miles, the replacement rates just explode. These are no longer single component replacements. And the reason is, and it's you guys that are telling us this, plus industry information, that on average, the vehicle's age can be anywhere from 12 to 16 years old, with anywhere from 125,000 to 250,000 miles on that vehicle, whose preventative maintenance has been ignored. So you can see where these percentages come from. And the danger here is, if you and I in the industry doesn't get a handle on it, we're afraid you will begin to see warranty will begin to be declined if certain things aren't happening through the repair process. What we found out through our own research here is most major shops do not indicate a flush on a water pump repair order. The interesting thing is, if I teach 100 shops and their technicians in a course of a day, the one question that I will ask is, how many of you have a flush machine? Out of those 100 people, which may represent 50 to 60 shops, we may get less than 10 will raise their hand. The follow-up question is, how many of you actually use that? And almost all of them go down. And when we begin to ask why, it's because if we use that flush machine, it adds cost to that service. And if you think about what the customer's doing, they're calling around trying to find the best price of the job. And they may call Bob's Auto Repair and ask me, how much would it do for me to replace a water pump on their vehicle? And I'm just making up numbers now. It can be $450, but they call Sam's Auto Repair and he wants $650. They don't know the difference in what's going on, so they always lean back to the shop that has the cheapest rate. So it's time for us to help our customers understand, Mrs. Smith, and she's my fictitious person who owns the vehicle. Mrs. Smith, you own the vehicle, and we appreciate you bringing it into our shop. But my question to you, Mrs. Smith, is, would you like me to fix or repair the problem correctly? It's a yes or no question, because they own the vehicle. We have to help them understand what these failures are today. And something else we have to also understand is, this can happen. We can contaminate a brand new original equipment vehicle the first time it gets its oil changed, if it's taken somewhere else, because think of this. It just went into whatever lube, and I'm not picking on whatever lube. I'm just saying the car was taken. I bought a car in Miami, drove it all the way to San Francisco, California. 3,000 to 5,000 miles later, I take it in for my oil change. And when it goes in and they change my oil, the dealership's closed. The guy looks over and happens to look through his 18-point check or whatever they do that the coolant bottle is low. The question is, what did he just top off that coolant system with? So the key issue here is, number one, nobody knows what the last guy put in it. As I began to do a little research, you think about Henry Ford. Years ago, that's kind of where it started for us, isn't it? And so Henry Ford, as he began to manufacture his Model T, the first couple of model years, he did have a water pump, but they removed it. And because they were able to move the water through the system by what they call thermocycling. But if you look on the left, and this is just a simple timeline, if you think about the years ago, the radiators were made with copper, brass, tin, lead. There was iron in the system and a variety of other stuff. But today, in the mid 80s, they moved from brass and tin over to aluminum. So most of the coolant system today is made with aluminum. But yet, for the most part, we haven't changed our repair practices, and it's creating failure. In 1995, the coolant changed from ethylene glycol base to an extended life coolant, or an EL. Mid 90s, molded coolant hoses changed from neoprene to EPDM, and then we added our modular hose line in 2018. So as you begin to think about the coolant system, its core process is to move heat from the engine compartment and to keep the passengers warm, right? And it has all these components that it's made up of. But when we think about system smart, we have to think about how one failing component can impact the rest of the system. Because if this coolant system is not doing its job, number one, the admissions system can't do its job either, right? So begin to think about this in a whole different attitude than we have in before. You've got the radiator heater core, radiator hoses. Now we have the modular hoses there, and you'll see some information on those in just a minute. We've got the caps. Water pumps now can be mechanical, driven by a belt, can be gear driven, it can be electric, it can be convection, or you can have all three of those in one system. Thermostats can be standard. They're now map driven. They'll have a little element down in that thermostat that can, so when the OBD2 calls for, we need to open that thermostat sooner, then what it will do is it will place or put heat down into that wax pellet that forces that wax pellet to expand at a much faster rate. So the harder the water pumps or the coolant system is, the water pump, the lifeblood of the coolant system is the thermostat. And that's why it's so important today to understand how these systems fail. If you look at a 1 liter EcoBoost, 3-cylinder engine. Think about this. It's all aluminum now. It has different pathways cooling different things that's being monitored or utilized by the OBD2. So, but look at the hoses themselves. They're also today modular in nature. The modular hoses really began in and around the early 80s, but back then they were very simple in design. So you'd have 1, 2, or 3 hoses, and you could replace 1, 2, or 3 hoses. But again, we talk about system today. Vehicles are anywhere from 12 to 16 years old, up to 250,000 miles. Typically, this is what's coming into your shop, and maybe they've replaced one hose. Well, at some point throughout all these years, this whole system has begun to heat soak, heat bake, and be impacted by the quagmire of coolant that's within the system. The last thing we need to do today is give this water pump a heart attack. This, and as we all know, we certainly don't want any of these vehicles to overheat. Look at the 2000 Ford Focus. Remember Henry Ford's thermocycling or siphoning back during the early days of the Model T? It's using the same technology again today. So we have an electrical or a mechanical water pump, but it also has a turbo. So as soon as you turn the vehicle off, the water continues to siphon through. Remember, heat rises, so it goes to the top of the radiator and then trickles back down and then continues that till that point until it cools itself off. When you think about the modular hoses in design, there's all type of applications, but the real reason they're here today is that it saves the OEs a tremendous amount of time on the assembly line. But we also have to remember that all these hoses now, in years past, we used to talk about, hey, if you have one hose that failed, you should really seriously consider replacing them all. This is probably more important now to speak to this than it ever was before, because all these hoses have been impacted by the failure of both internally and external things that are happening to it. Along with that, the plastic components are begin to get hard and brittle. You can see the branches. I'm working from top left. Some of the ones to the top center will have check valves. Now they tell us that this check valve is actually a small thermostat that opens and closes. It can have filler necks, quick disconnects. It can have sensors in those. You may also see a flow restrictor. If you remove a hose and it's got a hard spot in it, that's not a knot within the hose. That's a restrictor that will restrict the flow of that hose to wherever it's going within that engine compartment. You can only put a hose with that restrictor back in that system. So the branches can go anyway. But the thing to remember is, and if we've got a long line situation, let's say we have a school bus, we've seen up to pressures as high as 40 pounds being forced back to the school bus under operation. And even though that cap is designed to release at 22 pounds, it can still, in certain areas of this system, can build up tremendous amount of pressure. So what's really driving this problem? It's lack of knowledge, mishandling of contaminated coolants that none of us really understand, because we're still dealing with our repair practices from 30 years ago. So we reached out to Amalgatech, and what we wanted them to do is help us understand where these failures are coming from. We also reached out to Donnie Cipher at the time. Our home office is in Denver, Colorado. Donnie was kind enough to be a part of this and to help us make this information help you understand it or make sense for you. So as we begin to work with Amalgatech, that's their rig in the front, in the center, and what they would do is they would begin to mix coolants, because that's what the original conversation was about, was intermixing of coolant. But what we found out, that was really not the main issue. The main issue was the condition of coolant that was already in the system that was creating the damage. So as they begin to and I'll show this to you in just a minute. These are hockey pucks on the right. So they would take aluminum. Remember, the coolant systems today are primarily aluminum. And what they found as they begin to mix the coolants together, if they were compatible and there was no damage, it would create basically no damage to the aluminum. Now I want you to think about this. Aluminum today is very light and very thin. And if it's not coated and protected correctly, and then we're mixing incompatible coolants, it can create damage very quickly. So if it's not compatible, and very specifically, they talked about, Amalgatech talked about, if we mix an oats organic acid technology with a Hotes hybrid organic acid technology, it can begin to erode that aluminum very quickly. Bottom line, at this time, they told us 17% of intermixing creates contamination within that coolant system. So this is what they returned to us. If certain conditions exist in the coolant system, mixing dissimilar coolants can create a reaction. Number two, metals are failing because of lack of protection for the diluted inhibitors. And if you think about this, these are additive packages. They have buffers in them, and they have these inhibitors that help protect this stuff. Number three, and this is where we really begin to come in on this message, because this whole research was completed for one thing, and that was to try to decide, or to help us understand what was creating failure for our water pumps that should give us 100 to 150,000 trouble-free miles. It pointed back to one thing squarely, and that was condition of coolant. Number three, suspended solids in the contaminated solution are destroying the water pump seal prematurely. Bottom line is 95% of the water pump claims submitted back to us indicate there's no flush completed at that time. 66% of the water pump seals, the direct failure is the direct correlation is back to these number three, suspended solids that are suspended in that coolant that are sandblasting that to death. So we have really confusion within the industry. And number one is the good question to ask when our customer comes in. If they give you any challenges on about replacing your coolant at all, here's a great question to ask them. Mrs. Smith, can you verify that what the last guy put in your car? Can you verify your coolant's never been intermixed? And of course, we all know that answer to that is no. So we have condition on coolant, the condition of coolant that's creating these issues. The only thing Gates can recommend is application specific. There's an SAE number on that coolant package for that vehicle. Can you buy that at the local parts store? You probably can. But the encouragement here is to introduce only application-specific antifreeze into that vehicle. When we talk about changes or confusion, coolants in any make, any model, just pour it in. I'm very proud to say that was, for the most part, was on the front of most coolant bottles a couple of years ago. And through our research and helping get this information out to the industry, I'm very proud to say that a lot of the coolant companies have begun to remove that off the front of their bottle. Extended life coolant, 150,000 miles. Well, that's great, but hey, can you even tell us if has it ever been intermixed? You know, has anybody just put tap water in it? If it is, the flags have to go up at that point. Heavy duty coolants. You know, I saw one the other day, and this is coming. On average, heavy duty coolant for the trucks today, 750,000 miles, up to 1 million miles going forward. But you know what? The coolant, the engine manufacturers, for the most part, have removed the coolant filters on the diesel engines because of poor preventative maintenance practices. They weren't being replaced, and as the system got dirty, it would begin to load up the coolant, the filter itself. On the other side of the coin, we used to, on the heavy duty side, recommend that we should use a filter cart. For the most part, they have been removed now as well. So we're going to ask a coolant to run 1 million miles, and there's no way to check to see if it's ever been intermixed. We're asking, I think ourselves, we're creating a lot of issues for the heavy duty system in the future, I think. Current testing is not adequate for today's coolant, and I'll address this again on the backside. Today, hydrometers are no longer recommended by ASTM/SAE. They recommend refractometers. The hydrometers are up to 23%, 23 degrees inaccurate over a refractometer, and we'll talk about that in just a few minutes, because that became during Monday's session, that became a talking point. Customers again drive the repair process. They don't want to pay for it. Well, you know what? If they don't want to pay for it, your reputation exists around the work that you do and the longevity, that repair that you did, that keeps them from coming back. We found through our own research based around this one message that we can see your customer back within 7 months, 7,000 miles, not only with the same damage, but with additional damage. So as you begin to think about this, how have we trained everyone? Do they understand the changes in the coolant system? And if we don't know what kind of coolant's in that system, then this may be why you're seeing a much higher rate of failure modes within the coolant system itself. Is the coolant system locked down? I taught last year. I taught at a emergency vehicle training session, and after we got through with this, had a gentleman come up and tell me that in one of the boroughs of New York City, they just went through and took everything you could pour over into an engine out of their shops, and the reason was because of failures just like this. They were putting anything in that system. So now, if you have a fire truck that comes in off location and the coolant bottle's low because it's been running at high idle for a day, 24 hours, you have to pick up a number and call them, and they'll send a tech out to put the correct fluid into that vehicle. So we have to think about, what is your first aid when the customer comes in and says, you know what, I didn't have the correct coolant, so I just put tap water in. Your red flags have to go up, and because now it's time to say, you know what, because you've done that, you've contaminated the system, and we have to flush it out and replace the system when we complete our repair, as we complete our repair. So think about this, and I want you to think back a couple of years, and you may still see this, and if you don't believe me, go look at your own shelf at the back of in front and back of the coolant bottles that you'll have. And a couple of years back, we used to address everything with, when you looked at a coolant bottle, it would say universal, any make, any model, just pour it in. But you know what? Color means nothing, number one. The only color that was standard was green, and that was ethylene glycol. So if you think about this, we have to, because of the additive package and the buffers that are in it and the inhibitors that are protecting the metal, these aren't interchangeable. Can be used for top off. You can use water for top off if that's what you want. And the question you have to ask your customer, if they're not going to allow you to do a full flush, oh, did you want warranty when we do our work? Oh, absolutely. Well, there's no way for me to know if your coolant's ever been intermixed, Mrs. Smith. You can't verify what the last guy put in it. So I don't know. And from that reason, I can't guarantee the repair. So as you begin to think about this, pull out these bottles, look at the back. You have to look for the fine print. Now, it's better defined now than it was a couple of years ago. And here's one that stated, if you want to see the long life of this 50-50 pre-diluted antifreeze, a complete cooling system flush and fill is required. And the question I have to ask you is, what part of required don't you understand? And don't feel bad. It wasn't you, it was me as well, because I had never read the back of these bottles until we started doing this research, and we found so much fine print in it, it just didn't make sense. Here's one right here, and I love this one because they tell you right up front. Statement: oats chemistry may be damaging to cooling systems that specify oats chemistry. It's not that it may, it will be damaging. Now, again, I will say here that I don't recommend antifreeze. The only antifreeze I can recommend is application specific. If you have questions around antifreeze, contact your antifreeze manufacturer. We also don't recommend any type of chemicals to flush the system with. We're just trying to bring the awareness of what's happening to the failures within the coolant system. I want you to read this. This is another eye candy chart, and this is available in this presentation, and you'll see the recording as well. This was provided by Amalgatech. And when you talk about on the left the different types of coolants, what are the pros and cons of those? And we're only going to have just a minute to look at the cons. And as you read that part of it, you'll see they don't play well together. Now look at the right side and think about the inhibitors that are in each package of the antifreezes, depending on what it is. Look at the functions of that and think about the disadvantages of these. And you'll see for the most part, again, they're not intermixable, but yet we continue any make, any model, or, and you think about this, Mrs. Smith may have a grandson or a son that borrowed her truck one day and went out and maybe mudded that afternoon, and on the way back home, he saw that it began to run a little hot, so he stopped by the parts store to buy a gallon of antifreeze to go in it. And so the question then becomes, what did he put in it, in the system? What did he purchase? Probably anything that was on sale. So you can see how a lot of this stuff begins to get intermixed. Amalgatech told us, and this is their coolant triangle of protection. Mostly water it is. We have freeze suppressants that lower that boiling point and raise raise that boiling point and lower that freeze point of that coolant. Look on the right side. So we have buffers there to help protect that metal, but we also have corrosion inhibitors that form a thin coating on metal that restricts access to the metal itself. Now it may take 3 weeks depending on what inhibitor it is. It can take up to 3 weeks for it to etch itself in to coat and protect that metal, or 3,000 miles. So you can see when we do a partial replacement of coolant, Amalgatech told us that through their testing, a lot of times if we do what I call a drop and drain, I've dropped the antifreeze out of the radiator, I've facilitated my repair. Hopefully I put new coolant back in, and what we think is it's going to boost what's in the block. Amalgatech said through their testing, it actually went the other way. It depleted what was in the block, just depleted the new antifreeze that we just, and contaminated that as well. So now we're back to condition of coolant again. When we do any type of replacement like that, a partial replacement, we just stripped off that inhibitor package. And you can see a lot of that, and we actually see a lot of this in returns back to us when someone sends a water pump back and it has cavitation up under it. What happens is, and if we're dealing with heavy duty truck, we understand this is wet liner cavitation. That means when that diesel bust off, that cylinder bust off, it blows the coolant away from that iron cylinder or metal cylinder, and then it comes back with a vengeance. So that creates a low pressure, and it comes back with a vengeance and shot pings that metal. It's the inhibitors that coat and protect that make them glance off. If you ever remove a water pump from a customer's vehicle or see this type of cavitation, it's normally the first sign that you've got your coolant's already broken down. The inhibitors are no longer protecting. It can't glance off. All it can do is shock ping. Look on the bottom right, or bottom to the bottom left. And we talk about the purpose of a coolant system is to remove heat. Well, here is, and the funny thing is this picture came from, they said, and it's most prevalent right now in the state of Texas, where the millennials don't want to purchase coolant. They'll just put the hard Texas tap water in there, and that's a result of that. So we had the calcium, magnesium begin to drop out. You can possibly have some of the silicates begun to drop out, begins to put a thermal barrier on the inside of the coolant system itself, creating heat. And that's why we say nothing but distilled water, deionized water, or a 50-50 premixed, because we're introducing calcium, magnesium, and chloride into the system. As we go just a little bit deeper, I wanted to provide you an update as well on the hoses, because remember, we moved from neoprene to EPDM, and I'm not going to spend a lot of time here, but as you begin to look at this, you can see the top left. A lot of times we see clamp damage, it's too tight. There's no need. A rubber hose will actually take a bond to the nipple that it's on. Silicone's different, but rubber will. So there's no need, over a period of time, there's no need to tighten that clamp all the way down to where you see metal or rubber squeezing up through the serrations of the clamp itself. As these hoses and these plastic components sit on top of this engine, they have a tendency to heat soak or heat bake, and that begins to help them kind of over cure and become a little harder and brittler than they did before. Look on the bottom left. That's from controlling contamination. Anytime you overpour something like oil, or if you're using a petroleum-based degreaser, it begins to break down the adhesion properties of the hose. If you also have a head gasket leak, or you have any type of oil contamination inside that coolant system, there's no way for you to clean that out. Once you can do a chemical wash and get a lot of it out, but it's already done the damage to the hose. Because when we think about the inhibitors as they're migrating through the system on a normal day, it's layering that protective material over everything. It's also layering over that rubber, but it can't keep it on the inside of that tube, but it can't keep oil from seeping in. So it's primarily, it was there to protect the metal. Look at that center. That's internal heat damage. This is when things begin to get hard and brittle. Look on the far right, ozone damage. If you got a hose that's sitting close to an alternator today, we moved from 60 amp alternators to over 200 amp alternators. I saw a transit bus alternator the other day, 600 amps, tremendous amount of ozone being pumped out from these accessory. Far right, abrasion damage can either be rubbing on something or internal chemical contamination can cause that failure as well. And ECD, electrochemical degradation. Now, years ago, it really used to be prevalent in neoprene hoses. Today, we manufacture with with EPDM hoses. It was more prevalent in neoprene hoses. I think that's what I said. Anyway, what happens is when as the coolant's running, if it's really dirty, it sets up a battery type effect because we've got tin, iron, different type aluminum, different type of metals now in the system, and it creates a battery type effect. This is also can be exacerbated by the plastic headers on the radiators, because as it sets up that battery charge, as it comes out of that upper nipple into the top radiator hose, it's looking for a place to discharge. It's trying to go to ground. And the way it goes to ground is it will actually fire about 2 to 3 inches out inside that hose, and it creates a serration. So if you ever take a hose apart and you see little rows that are kind of etched into that, we have to understand that's because you had tremendously dirty coolant that was creating this ECD type effect. Now, Gates compounds against this, but you can help yourself and help remove a lot of this by simply flushing the system with some flush tool that you have available. One way to check for ECD, of course, is use a voltage meter, 3/10 of a volt. Anything I found that voltage is very personal over the years. A lot of people have different numbers for this, but the bottom line is if you have voltage in that coolant, then two things: we've got extremely dirty coolant, or you can have bad ground straps. Are the first two places that I'd begin to look. When the modular hose failure, so we've got all these plastic components that are now becoming really hard and brittle. And I want you to remember, at this point, the hose it's getting close to its duty life. It's our customers that are asking us to extend that duty life past the potential that it was made to run. So this is the information that we have to bring to them, because they're looking at you to guarantee that repair, and you have no control over the failure. When you think about these plastic components, and we've had so many people come up to us, and this is why we actually brought the modular hose line out, was we've had so many people say, I go to move a hose, and as soon as I move it, that plastic component breaks. So our thought was, should we offer plastic components? Yes, but it's the awareness around the hoses are right there ready to fail anyway. So why not go ahead and replace as much of this assembly as we can? I also want you to know that the O-rings, they're not standard off-the-shelf O-rings. They're different shapes. And so just to replace that O-ring, if there's a leak, just to replace that O-ring can create an additional leak. And if you remember back to the second or third slide that I showed you, the number one reason for coolant system failure was a leaking system. So let's make sure we don't set our customer up for failure before they leave. This is from a warranty sort that we had last year, and you'll see that on the right, this is stuff that's returned from our customers, and we'll go through that trying to determine what the failure modes are. I want you to think about that green catch basin. If you're doing a coolant system repair, use a sock, use a painter's filter or something to catch that coolant, so you can show your customer this is what was in your coolant system. From this point forward, I have to flush this system out if I want to protect a couple of things. Number one, the impeller on that water pump and the water pump seal itself. Because if you just do a replacement and 7 months later, remember 7 months, 7,000 miles on average, they're back again. This is the reason why they're coming back. And here's the way I talk about it. We call it STOP, second time, zero profits. If I'm replacing the same component for a second time for the same reason, it's not that component that's creating the failure to begin with. And that's why we say be system smart and do a little more diagnosis to try to pin down what the actual cause of the failure was to begin with. So as we think about all this, by the way, that big blue dumpster of water pump, over 80% of those weren't even Gates water pumps. That's your customer just trying to help you and give you what you think to replace what you think was bad. But the bottom line is, at some point, and this is what we're trying to get stopped, if we can all come together as an industry and understand it's the condition of coolant that's creating the vast majority of these failures because we're not renewing it, then at some point, just like with the air conditioner compressor, you can't replace just a compressor today. You have to do the complete job or the warranty void, and we don't want to get to that point in our product sales. These are just some of the pictures that we've gotten from this, and these are all water pump failures, right? No, none of these are actual water pump failures. They were all forced to fail by something else in the system. These are just a few pumps from the water pump sort. Here's one, and it's electrolysis. So we took it off. It's dark colored. You can look right up under the seal itself there, and you can see where it's been etching or firing through the course of its life. This is there was no installation date on this, but you'll see one in just a minute how quickly this can happen. Here's another one. I love this one. First off, the belt was off tracking on this, so they had a belt problem. But in your own mind, think about what's the damage here? What was creating this discoloration? Well, what it was primarily, it was lack of inhibitors, so they had rust. But I want to show you one more picture. How would this change your mind? It was just rust. They had a tremendous amount of particulates that were suspended in that solution that sandblasted that impeller to death. So now we have a low flow situation, and this was installed less than 6 months, I believe. Here's one that they did give me the number on. This was installed on 3/25/19. It was returned on 5/21/19, and they talked about the bearings felt like it had a soft spot or a flat spot on it. But I want to show you one other thing, and I'm going to back out here, and I'm going to go to my camera just for a second, and let me tighten this up for you just a little bit. This is a water pump off a Volkswagen. I use this for demonstration purposes because it's small. It's a cutaway. This is the unitized seal today. The water's flowing this way. Okay, so as it flows, well, let me turn it this way because I think that probably looks better on yours. So the water's flowing this way. This is the water pump seal, and you'll see this is the blue thing. Now I want to show you a seal. This is what the seal looks like. It's just this is a heavy duty seal, and you'll see that it's spring loaded, and I can push it together. So I have two silicone halves or seals that are being pushed together by the spring. One is stationary and pushed into the cavity of the water pump. The other rotates with the pump. So as the water goes this way, it uses that coolant to lubricate that. And if that coolant is loaded with particulates, particulate matter, it can sandblast this seal very quickly. This is why you may replace a water pump only to have them come back a couple of weeks later with a drip at the weep hole. You have to ask yourself the question, did we do a full flush? Not a coolant replacement, but a full flush to get all that stuff that was in that green catch basin out of the system. So as it flows through here, it comes out. Here's the catch basin behind that. So this is an open area that it catches any drip that comes out that migrates down this little channel, and then comes, here's the catch basin or a cap. Now, some of them are open. On some of the higher VIOs, they actually will put a catch basin on there to keep the technician from panicking, or the customer, is if there's a drop of coolant on the ground. It's okay for it to weep just a little bit. It's when it's a constant drip that we have to be cautious of. And I talked about, I would show you, this is one of the aluminum hockey pucks. That's a $30,000 puck. But you can see, and this is where they mix Hotz and an Oats together, how quickly it can do that damage to that aluminum. Malgatech, they said, in less than a week, a little over a week, was able to dissolve this whole aluminum hockey puck. They could mix this stuff so bad. So it's kind of an eye-telling type thing. This is where some of the issues that are going on, as we bring this to you. We've already talked about the water pump seal. I call it right hand, left hand. We have to make it real simple for our customer. Now, my right hand's on your left side. So on the right hand, condition of coolant, inhibitors are not protecting the metal. And now we've got, as this quagmire continues to build, it begins to attack that aluminum or the metal on the water pump itself. On the left hand, which is on your right, the suspended solids in the condition of coolant or the coolant solution are destroying that water pump seal. The only acceptable procedure that we found that will fix this is really a full flush at the time of repair. But and that means that we have to at least approach our customer, and if we see some very specific failures like we're seeing today, and especially show them this stuff. You've got more of this left up in the block that we have to flush out. These are just some pictures, really nice pictures that Expected Premium began to share with us, and I'm going to go through these very quickly because we're really at the time, past the time I wanted to complete this. Coolant mixture failure, plain water, inappropriate rust inhibitor, hard Texas tap water right there. Stop leak, how many holes are in it? What's the purpose of a stop leak? To stop up holes. How many holes are in a radiator? A lot of them. Thermocycling, something you need to be aware of. On these older model vehicles, Expected Premium told us through their research that the thermostats are being the rod that goes up and down, the stainless steel rod is beginning to get it's beginning to not operate as it should. And instead of opening like it should, as it begins to go up, the rod itself is now rough, so it can't open all the way, and the springs kind of pushes it back down. So it's chattering, and they call that thermocycling. That puts both heat and pressure on the upper header of that radiator, and it can split right off that neck. Improper flush, bottom left, depleted inhibitors on the right. And the list just went on and on and on. These are about 35, 40 slides they sent me that I just pulled a few out. But you can see the conditions. When you pull a radiator off that looks like this, you immediately have to tell the customer, I have to flush the system. Flush and fill procedure is the one that we found is the only one that's acceptable to make sure that customer's not coming back anytime soon. I think most of us probably live in the water hose wash procedure world. I've dropped the antifreeze out of the radiator. I do my repair and then fill that back up, thinking that it's going to boost and renew what's in the block, and it's not. It's actually going the other way. The drain and refill procedure is the least acceptable, and we highly recommend that we use some type of containment system. You know, we advocate responsible flushing and containment, so just don't pour it down the system. So you can see if you don't have a flushing machine, if you do have a flushing machine, please get that out and begin a process to help your customer understand we have to do this to make sure that you're not going to be back in a couple of months. If you don't have a flush machine, then there's a variety are out there. Through the Monday's meeting, we were asked about that. I'll show you a little the Power Clean tool we have, but I'm going to leave that up to your decision on really what direction you want to know. I would just highly recommend that we have to get the particulars out of the system. And when I talk about flushing, I'm not talking about coolant replacement, because coolant replacement simply is just that. 5 minutes or less, we're just swapping fluids out. We're not cleaning the system. And you know what? Yeah, I'm gonna spare you the opportunity to see this, because my in making changes to this, I actually killed the link that showed this. But let me explain this real quick. This is a pulsing unit, and it's a water pick on steroids. You could brush your teeth with this if you wanted. It hooks up to shop air. You dial it down here to where it's 28 pounds at the head, and it creates a pulse type effect. So it hooks up to shop water, shop air, and very quickly you will fill that like that radiator up, and then put this in the bottom of it and pull that trigger, and it will begin to pulse, and it gets everything levitated up, and then we'll pull that back and catch all that fluid coming out. And you can do it again as many times as you want. We're almost done here. But the best practice of what we found on a rule of thumb is your customer can't verify the validity of the coolant, then you know what, at time of repair, especially if you're seeing any type of discoloration, pitting of the metal itself, then it's probably important for us to think about doing a complete flush. You know, anytime there's a coolant component replaced, flush that system. If you suspect the coolant is contaminated, let's flush that system. If your customer can't verify at all, flush that system. If we just talked about discolored, pitted, rusty, then it's time for a full flush. If there's an overheat situation, certainly I would highly recommend flushing and renewing that coolant, and replace the thermostat and replace the cap at the same time. If you see voltage in that system, you know you have ECD, you have electrolysis. It can be from bad ground straps. Think about the guy that just pulled in. He's got a truck. He's got a trailer hitch on the back. He's got a new trailer or a boat that has the lights hooked up, but it's improperly grounded. All of this can create havoc for that electrolysis in the system. Check those ground straps. We've already talked about stop, second time zero profits. Make sure that if you're replacing coolant, you're looking to use deionized, demineralized, distilled water or a 50-50 mixture. Please do not use tap water. And the use of hard water can really escalate these systems to help them face. If there's any doubt here, flush it out. So to kind of bring it to full circle, when we do a coolant replacement or a repair, let's not make it a Band-Aid approach, because if it's a Band-Aid approach, then we've already set the customer up for failure before they even leave the shop. they're coming back. So with that, I certainly appreciate it. I've got 2 more slides to show you, but I just want to clarify a couple of things that I said. I ask you to do your own research, and I put this in from last Monday's because there's a very, very nice document that talks about not using a refractometer versus or a hydrometer versus using a refractometer. Hydrometers are no longer accurate today, and they're only good for ethylene glycol. You cannot use them on propylene glycol, and I know that people buy them because they're cheap. They also use the balls, so they're gauging specific gravity. But if there's bubbles in that hydrometer, or as the balls go up, if they're contacting the inside of that hydrometer, there's friction, and they won't read correctly. You also have to have a cooler vehicle. You can't use this on coolant that's hot because you'll get an inaccurate reading. Where to the right, a refractometer actually bends light, so it's gauging the speed of light of the material that it's looking through. It can also be temperature conscious, but they use a automatic tensioning thing in it, the way they build it, to compensate for that. So whether it's a metal versus a plastic type refractometer, do your own homework on this. But just know, based around our research, this is where you're finding a vast majority of the failures and warranties and comebacks that you're seeing within this coolant system. ASE Society of Automotive Engineers, here's a couple of great papers. Unfortunately, these aren't free to the public. There's cost associated with that. So, hopefully one day we can find some of these, and you may find them out on the internet somewhere. ASTM, American Society for Testing and Material. Here's one on the hydrometer. It talks about that. It talks about the reef. So a hydrometer under a standard testing, a very specific standard testing method that they use, they found hydrometers to be off plus or minus 8 degrees. But under real life situations, they're off 23 degrees. So you can see the difference that makes, because you think it's rated down to 32 below, it may be just rated to 30. So that's the difference of a hydrometer to a refractometer. And if you'd like to visit Amalgatech's website, it's there as well. So with that, Dave, I'm going to really turn it back over to you guys. If you'd like additional training, here are some of the websites you can go to. Navigates, if it's not on your phone, if you're looking for these modular hoses, you can look these up on your phone on the Navigates app, and just look up the application, and we'll give you everything that Gates manufactures for that. And if there's a modular hose configuration there, you'll find that there as well. At the end of this, you can push for these are live water pump or live video presentation, very short, 3.5 minutes. That little video I wanted to show was here. That's the power, how we set it up. Here's the longer why we're doing this. And then water permeation for those that are dealing with a diesel application that has silicone hose. Water will permeate at a much greater rate over the glycol. And what that means is, and that's why we have to use a refractometer here, what that means is you may be placing a 50-50 mixture in there when you only needed to put in distilled water. So with that, thank you so much, guys. I know I went a long time, certainly appreciate it. Had a lot of information here to share with you. And if we have any questions now, I'll leave that. We'll get back to that point of it.
Bobby, this is Dave. I just wanted to say thank you for some real new insight and things to shake things up in the way to look at a part of vehicle service that I think we've kind of just taken. We're still here. And anyway, Dan, while Bobby's trying to maybe get his audio going again here once, what are you finding in the questions pane? You got any common threads as far as the questions?
Okay, Dave, can you hear me?
I can.
Okay, so first I think you should address how folks can get a recorded copy of this webinar, the certificate, and what we intend to do for those who have attended and how that's going to take place. Can you do that for me first? Then we'll see if we get Bobby back. Dave? Well, I think we might have some audio problems here. So I will just address that
Right.
you
I'm
should.
back, Dan.
Okay, go ahead and hit it then.
Right. Yes. So about a day from now, you'll be receiving an email automatically from a system, and it'll say, thanks for attending our webinar. Or for those people that registered and didn't, they'll also get an email, but it'll have included in it a link to a recording of this session. And also for those that attended, there will be a connection to a PDF certificate for attending. What are you seeing in the threads on the questions pane, Dan?
First,
Anything?
thanks, Dave, because that handles a bunch of the questions. They were wondering how to get that, so I just want to repeat
Okay.
that. From Lou, he asked the hybrid, plug-in hybrid, and electric vehicles and the coolant systems on those. If Bobby's still with us, is he available to answer that question? How do we address those cooling systems? Bobby, are you still there? So I think we've lost him, Dave. So
Okay.
I would say that at this point, I think we'll let the questions go specifically to that on this link right here in the bottom left corner. I believe I've got to shrink my screen. On the training site, it might be. There's also a clean version of this webinar too, but bottom line is you can get it from us through the email that we'll send you. So because we're not the experts in coolant, it would be a shame for us to answer incorrectly questions that you have about coolant. So I think we're doing that correct, Dave. Unless Bobby pops back in, I think I'd let the questions go and we address those as we need to via email.
Yeah, Dan, I'm going to just make a statement real quick. And I think, speaking for maybe many people, is that the one issue is people wondering, why do we have all these different coolants now? Is this just a conspiracy by all the different manufacturers against us, in service? And I think you really have to think about the materials that Bobby outlined, showing all the differences, and then the types of things that the manufacturers are trying to protect in their systems. And I think that lends some of the reasons why we're seeing it. I can't tell you exactly how many different parts there are or components of it. But one example you might want to look up is just look up at the coolant system. You can do a Google search on this. The multiple cooling systems that a Chrysler Pacifica hybrid has. There's multiple coolant jugs, different formulations, and some interesting things there of why you really got to pay attention to some of the subject matter that was presented here today. So I invite you to research that. I think Bobby, by showing some of the labels that he had on coolant bottles, kind of whets your appetite a little bit. But maybe if for nothing else, this raises your awareness.
So this is why it's time for us to everybody step back. It's the customer that's driving this for us. They don't want to pay for it. At some point, we got to say, you know what? You own the vehicle. This is a light bulb type question. You want me to fix it or not? And if you want a shortcut, maybe you as a professional can't afford the liability that's associated with it. So take it on down the street somewhere. I'm just saying. So do your own research. There's a tremendous amount of research that can talk about this and do this. And I would go for a refractometer. Do a very specific search. And you can see I'm not trying to promote anybody's side over the other. But if you do a very specific search on why use a refractometer, there's a very nice document that was written up there that is available to you that has a tremendous amount of information in it.
Bobby, this is Dave. I have a question about the practicality of flushing and what goes on in shops. So, for all intents and purposes, they're going to be using tap water, right? Supplied there, and you get done with the flushing, and there's going to be residual tap water left in the block and other areas of the cooling system. How big of a concern is that?
That's a great question. Absolutely a great question. This one of the questions when we worked with Donnie Cipher, we asked him that because we're going to flush with tap water. And Donnie said, it's not really a problem for the most part. The blocks can hold up to 30% somewhere thereof. And he said, I use compressed air to blow out as much as I can. And he said, I can get a tremendous amount of it out. And then they always keep a gallon jug of virgin type antifreeze for that application in their shop. And he said, I'll just throw a little bit over extra in that block to offset some of the coolant that's still left to boost, or I hate to use the word boost, but to augment that tap water that I had in the block. There should not be enough tap water there in that to really make any real difference that we've seen and according to Donnie.
Okay, great. Dan, what else you got? Anything?
That was very perfect timing. Nick, Tarif, and Jeffrey were all commenting about, as well as many others. There's tens of them asking about flushing and what happens to the water in there. So well done, Dave. And then many of the comments I have here were related to the coolant side of it, but some asked, when you do flush, what type of flushing chemical might we use? Is that something you can comment to, Bobby?
No, I can't. And again, that's kind of my disclaimer at the front, because I'm asked over and over and over again about that. I'd rather you guys do your own, because everything's changed. Do your own research. I'm just showing you where the failure modes are coming from, and I mean, we can demonstrate and show you this over and over and over again. I'd rather you do your own research, work with your chemical manufacturer to find out what you think will work best, and then go from there. And I apologize. We've just had to kind of take a hard stance on that, because I don't want to, if I make that kind of recommendation and it may not be the right stuff for the hybrid vehicles or the full electrics, then I'm in trouble.
And then when you were addressing hoses, Cody popped in and he asked, can aged hoses, and the question that was asked was, can aged hoses introduce chemical agents into the coolant?
Not really. It normally, and what you're asking is, when I talked about the inhibitors will layer themselves on the inside of the hose. So when you remove a hose, if you see discoloration in there, basically what that is, that's the inhibitors that are laying there. For the most part, I'd say not. And if they did, it'd be so insignificant, I don't think it would really matter. But we have to remember, and instead of covering and coating all that metal, it's also layering all those plastic components, the internally that's in that system as well. But I don't think that would be a concern.
And then while you were away, before you came back in, I was trying to address any resources that might be available for technicians and service professionals from the Gates website. And you had that information on that page earlier. I think
Sure.
it was 1 or 2 slides towards the rear.
Let me go back. Oop, wrong way. Hold on. Oops. Here's my email address. Yeah, right there. There's my email address. If you'd like a copy of this presentation, just feel free to send me a note. Any information that we have around this, we'll be glad to share with you as well. We have emails, we have videos. As you can see, there's this will come to you if you request it in a PDF type format. Those will be live links for the videos that, like the one on the Power Clean tool, so you can see how that works. And then if you need any other information, just please feel free to give me a call or send me an email.
So that is pretty well going to wrap it up here for us. Thank you so much, Bobby. Appreciate you sharing all those resources to the service professionals. We really appreciate the time you spent with us and sharing this. Everyone here really appreciates the information. There's a lot of thank yous popping up, so we appreciate your time today. Dave, I'll roll it back over to you.
Thanks, Dan, and thanks again, Bobby, for what was really some great eye-opening information. Really appreciate it very much. Once again, everybody, this session was brought to you by the ASE Education Foundation. This is a new series of webinars that we are going to be offering on a regular basis. I wish I could tell you that we have a calendar published of what they're going to be, but just watch your inbox, because if you got notified for this, you'll be receiving other notifications of some upcoming webinars. So we really appreciate your attendance and taking some time out of your day. We know how valuable your time is. Again, just as a reminder, you're going to be receiving an email that will have a video link in it, recording of this session, and then of course a certificate link, which is a PDF stating that you attended this session. So on behalf of Bobby Bassett, Dan Baumhart, ASE Education Foundation. I am Dave Kappert, and we hope to see you at another webinar soon. Thanks for attending, everyone.